All right, let's go. First thing, little review. This is going back, I think it was last unit. What was angle 1 equal to? What was angle 1 equal to? Go ahead, Rachel.
3 plus 4.
Everyone remember this one? Exterior angle is equal to the, anybody remember for a little bonus here, what 3 and 4 were called? Remote interiors. There you go, Spence. Angle, an exterior angles, it was equal to its sum of the two remote interiors. Here's what I'm going to do today. Well, if angle 1 is equal to 3 and 4 added up, everyone agree with this statement that angle 1 has to be bigger than angle 3 all by itself? If 1 is equal to 3 and 4 added up, 1 should be bigger than 3 by itself, and it should be bigger than what? 4 by itself. All in agreement? So that's what this first theorem is saying here. The exterior angle of a triangle is bigger than either of the two remote interiors. So if I take my diagram right here, I'm going to ask somebody, give me an exterior angle on that diagram. There's only one on the diagram. Name the exterior angle on that diagram. Oh, it's secure. All right, let's roll. 6, give me the exterior angle in this diagram. Angle DCA, yep. So we're saying with this new theorem here that DCA is going to be bigger than which angle by itself now? Give me one of the angles it's going to be bigger than. DCA definitely bigger than 2?
Angle B.
Angle B by itself. And also, we're confident that angle DCA will also be bigger than what other angle here by itself? 11? Angle A. What you can't say, what you cannot say is that angle DCA is bigger than the one next to it. I have no idea. You don't know that either. We can only say that it's bigger than either of the two remote interiors. I cannot say it's bigger than the one next to it. No, we have no idea. I know they add up to 180, but I have no idea which one's bigger. We're not going to go by the looks. We are right on this exterior angle one before we apply it. All right, first diagram here. Tell me all the angles that are bigger than 7. Tell me all the angles that are, less than 7. So 7 is less than this angle, less than this angle. What I need somebody to do first, tell me a triangle where angle 7 is an exterior angle. Name a triangle in this diagram, because there's multiple ones, that angle 7 is an exterior angle for. That's the first job. 2, name a triangle angle 7 is an exterior angle for. JLK, the big dog. Yep. Everyone agree? Angle 7 is exterior for that one. All right. Name the two remote interiors for that triangle then. If 7's your exterior, this angle and this angle would be the remote interior for this triangle I've just highlighted. Name one of them. 4? Angle J, I'll put 3. Yep. So everyone agree? Angle 3 is smaller than angle 7. Do we see that? All right, what's the other remote interior then? I got angle 3. And what's the other remote interior in that diagram to 7? 10?
2.
2's part of it, but I need something bigger though, right? Because 2's not an actual angle in this triangle. I need an actual angle, so make it bigger. And you're probably going to have to name it with letters here.
Okay.
Which K?
Angle K.
I don't. You say K, but I don't know. Does that K, that K, that K?
Oh, angle JK.
There you go. So it's also 7 is also bigger than angle JKL. Is everyone seeing this theorem now being applied? All right, let me stop there. Wait a second. So Iris is saying that 7 is bigger than JKL. What's JKL made up of? 2N, angle 2 and angle 4. So shouldn't it also be bigger than 2N 4? Everyone agree? If 7's bigger than JKL and JKL is made up of 2 and 4, 7 should be bigger than each of those angles. Agreed? Okay. So it's bigger than angle 2 and it's bigger than angle 4 because 2 and 4 make up JKL. We're not done though, right? Is 7 an exterior angle for another triangle too? Other than the big one? You're darn right. Name it. Name it. 13, name the other triangle.
Triangle MKL.
MKL, yeah. Right? There's 7 exterior for that. We already have angle 4 down. We know it's bigger than 4. And what's the other remote interior we haven't mentioned yet? It's all 7 will also be bigger than what angle in this triangle? 12.
Angle 5.
Angle 5. Good job, everyone. Good work. So there's actually 5 angles. Angle 7 is bigger than. I'm going to let you, yeah, I know how this goes, but I'm going to try it out. Talk to people in your group. Can you find me angles that are bigger than angle 6? Don't tell me 7 because they're right. You can't tell me one's bigger than the other when they're right next to each other. Here's what I need you to do. Angle 6 is an angle. Pick a triangle. Angle 6 is an angle in. And then say, is angle 6 a remote interior to any exterior angle? So go ahead. Find me a couple angles that are bigger than 6. Bigger than 6. Six is an angle in what triangle? And by the way, I have 2 answers here. I have 2. I found 2 angles that are bigger than 6. 2. And I'm hoping you give me an exterior angle. So find a triangle where angle 6 is contained in. And see if you can find an exterior angle for that one.
Angle 8.
Anybody confident they found one? Yeah, what do you got?
Angle 1.
I like angle 1. Okay, angle 1. Here you go, everyone. Why angle 1? Angle 6 is contained in this triangle right here, MKL. Everyone agrees? And if you take a look, angle 1 is exterior to that triangle, isn't it? I know it's not on this outside, but it's on the outside of this triangle. So if angle 1's exterior, 6 would be remote interior. Exterior, always bigger than a remote interior. I like it. Great job. Anybody find the second and final one? Iris? 8. Yes. There we go. How does 8 figure in? New triangle. Yes, 6 is an angle in MKL, but 6 is also an angle in JLK. 8's an exterior. 6 is the remote interior. Good work, everybody. Good work. Questions before we get to a big one? Ooh, this one's a tough one. Tough one here. Ready? In triangle ABD, AB is congruent to BC. Everybody stop. What else is true? Work last unit. A theorem from last unit. If those 2 sides are true, Rachel, let's roll. Angle.
1.
Yep, is
Congruent to BCA.
Good work. Remember that in a triangle, congruent angles are across from congruent sides. We remember that one. Good work. So because those sides are congruent, so are these angles. All right, which one of the following must be true then? Is 1 bigger than 2? Is 1 bigger than 4? Is 3 bigger than 4? 4 bigger than 2? Well, oh boy. Yikes. None of the 1, 2, 3, and 4, none of them are exterior angles, are they? I can't. 1, 2, 3, or 4. None of them are exterior angles, so I can't use what I've been giving you today. Huh. But Rachel did just give us 1 is bigger than BCA. Everyone take a look at angle BCA for me. Anybody know an angle that's BCA is bigger than? Here, let me give you a little push. BCA is an exterior angle for this triangle on the right, so it's bigger than which two angles?
3 and 4.
Everyone agree? It's bigger than 3 and it's bigger than 4. Agreed? So let me put down a BCA is bigger than 4. Rachel, going back to you. What's BCA congruent to? What did you just tell me at the beginning? I'm going back to you for a reason. Angle. Wait a second. 1 is equal to BCA, and BCA is greater than 4, so what other angle has to be greater than 4? 1 and BCA are the same. BCA is bigger than 4. What other angle then has to be bigger than 4? 10?
Angle 1.
Yeah, right? These are the same exact angle, so what I could say is, oh, if BCA is bigger than 4, so is angle 1. Do we see how we got there? Had to know in a triangle, congruent angles are across from congruent sides. BCA is an exterior angle, so it's bigger than 4 and 3, but I didn't need 3. It's bigger than 4. Substitute it in. 1 and 4 are bigger. Any questions there? Because I got one more theorem for you. And I am not going to give it to you. You are going to figure it out on your own or in your groups. Here's what I need you to do. Number 1 is find the missing angle. You guys should be able to do that, no issues. Find the missing angle. And then dig deep by yourself or with people in your group. Dig deep. After you find the third angle in each triangle, find a pattern between the sides and the angles of each triangle. All right, go ahead. Find the missing angle right now. Find the missing angle. And then see if you can dig deep, please. Just don't stare at your paper. Dig deep and see if there's any pattern between the sides and where the angles are in each triangle.
So,
See if there's any pattern you can establish. And it might be just, you don't have to get too complex.
Where each angle is directly across from the largest side.
Wait, oh, so like, so, oh. It's like, oh, like the other side, wait. What if the small side is crushing the small side? Wait, oh.
More.
So it's like, look at that. 16 or 35.
Jack Hurley.
35?
Good. How are you? Yep. Am I? Yeah. Yep. Yep. Yeah. It's Andrea, student teacher. Yep. 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 Yeah, I guess Anne is supposed to put the student teacher's name in there. She was gonna take care of that. So yeah, yeah, yeah. Okay. Yep. All right. Thank you. Bye bye.
If you add this side and this side, you have two other sides.
All right. Anything here, huh?
So this side. It works every time.
Did you guys find 42? And you also found 35, right? Look, if you didn't see it, you didn't see it, but maybe. Anybody see anything? Or maybe you already know this fact already. Yeah.
The largest angle is directly across from the longest side.
And there it is. If you guys take a look at this, what's the biggest angle? 82. Look across from it. It's across from 7, which happens to be the biggest side. And it works for the smallest angle too. Smallest angle here is 35. Oh, not by coincidence. It's across from the smallest angle, our smallest side. All right, so here's your theorem. In a triangle, and again, you can replace biggest with smallest here. It doesn't matter. Biggest side is always across from the biggest side. Sorry. Biggest side is always across from the biggest angle. All right. Biggest side across from biggest angle in any triangle. All right, let's apply it. Get ready to roll. Get the calculator pumping. I need you to list the sides in order from shortest to longest. So I need to know all 3 angles first. So find that third angle for me. When you get that third angle, let me know. 3. When you get that third angle, Spence. Yep. Angle B for number 1. 92. Okay, 92. So we're listing this out from shortest to longest. So what would you, in that triangle ABC, what would be the smallest side? Here we go. 13, smallest side. What's the smallest angle, Trey?
BC.
BC, good. You want to keep rolling, followed by?
BA.
BA, and the biggest side would be? AC. Good work. All right, go ahead. Number 2, find the 2 missing angles there for number 2 before we say what the shortest to longest is. Can I get the missing angles when you're ready? 1. I'll move on. 6.
Is it 32 for STR and 73 for the one that's stuck?
You got it, Nate. 73, 32. All right, shortest to longest. What do you got for me? Shortest, 4. SR followed by ST. Yep, and then RT. Everyone's good? Shortest side across from smallest angle. Oh, we haven't gotten to anything yet. All right, next up. All right, tell you a little something about all 3 angles of this triangle ABC. Which statement's true? Well, I'm not going to be doing anything until I know what the actual angles are. Right? What is angle A equal to other than 3x? How many degrees are there? So what can I do with all 3 of these angles right now to set something up to solve for x? Because I need to actually know how many degrees are in each angle before I answer this question. So what can I do with those 3 angles here? 10. You have 3 angles in a triangle. What do we know about them? Add them up and do what? Say that again. Okay, yep. So I'm going to add them up. But I don't want to put a subtraction sign here. What do I want to put here? Equal to 180. Yep. So I'm going to let you guys do your algebra right now. You're going to solve for x, plug it back in, and I'll ask somebody what angle B, A, B, and C are actually in degrees. Did I change that one? Yes, I did. Perfect. Who's up? 6 when you're ready. A, B, and C.
A60.
Got it. Whoa, easy now. I can only write so fast. A60.
B61.
Yep.
C59.
Here you go. All right, ready to answer these. Is ABC isosceles? Nope. If it was, I'd have 2 congruent angles, which obviously I don't. Is AC the longest side in this triangle? Is side AC the longest side? I got a couple people saying yes and a couple people saying no here. Where is AC across from? 61. Is that the biggest angle? Yeah, right? And where's the biggest side located? Across from the biggest angle. There you go. AC is the longest side. Guys, we are right there on that fact. It's like we just haven't been doing it for the last 2. We sure here because 4 is the toughest as we're going to get. All good. All right, 4. Which in this figure, which one's the shortest? All right, which one's the shortest? The shortest. Well, before you do that, you still got to find the missing angles, right? I got to look at all the angles. You guys have shortest written down, right? Or no? It says longest? Okay. Cross it off and put shortest for me. So I'm hoping you found angle ADB. You got what, 60? And angle CBD 57. Now, I know most of you are going to say, oh, I understand this theorem today. You want the shortest? Let's see. The smallest angle is 53. Let's look across from it. Smallest side should be BD. Not smallest side in triangle BCD is BD, but I'm looking for the entire diagram, which one's the smallest one. And that may not be the case. All right, that may not be the case that BD is the smallest side overall. So here's how we're going to figure out overall which one's the shortest side. We're going to start ranking these within each triangle. So first, let's take triangle ABD for me. ABD. Rank them for me. Shortest to longest. Rank them. 1, shortest side in triangle ABD. AD, followed by BA, and then the biggest side in that one, BD. Good work. All right, and now let's compare that to the other triangle, BCD. Again, rank them from shortest to longest. 13.
BD would be the shortest.
You sure? Oh yeah, it would. Never mind. Yeah, am I sure? What else are you at?
The second would be CD.
CD.
And then BC.
And then BC. All right. We are looking for the shortest. So it is a battle right now between the two shortest sides in each of the triangles. So my answer is either going to be AD or BD. All right, because that's the shortest side in both those. Well, I think I got a problem, don't I? With one of them being the shortest side? Which one out of those two, AD or BD? And look at your rankings. Look at the rankings. We did them for a reason. Anybody got a problem with one of those segments being the shortest side overall? Because I certainly do. Look at the rest of the rankings. What's your issue, Anna?
It's the largest in triangle ABD, but the smallest in triangle BCD.
Which side?
BD.
Hey, how can BD be the shortest side overall when you guys said down here that there's 2 more that are shorter than it? So how can it be shortest overall? Everyone see where we're going there. There's no way BD could be the shortest segment if you ranked it the top one over here. There's 2 more. There's 2 that are smaller than that. So my final answer here, not BD, but AD. Okay, AD. Everyone see why I'm doing AD. There's no way it can be BD, because look, even in your rankings right here, you said there's 2 that are shorter than BD. So how can it could be shortest overall? All right, I need you to try one on your own, and that's number 5. You're going to determine, again, which one is the shortest. Again, which one is the shortest? Remember, rank each triangle. And then take the shortest from each triangle and compare them. There's going to be an obvious answer. One cannot be it, and the other has to be it.